In this video, we're going to look at characterizing a curve using maximum, minimum, and inflection points. So we're going to characterize the following equation into its parts, telling which parts are concave up or concave down, and showing where our minimum, maximums, and inflection points are. So we have our function f of x equals 2x cubed minus 3x squared minus 12x plus 5. For our first step, we're going to take the first and second derivatives of this equation. We can then use this information in the next parts to find our inflection and mins and max. So f prime of x is going to equal 6x squared minus 6x minus 12. Now we take the second derivative. F double prime of x is just going to equal 12x minus 6. Now that we have this, we can go on to step 2, and that's where we're going to find our inflection points. And step 2 and 3 can be done in either order, but we're just going to do the inflection points first. So we're going to set our second derivative, f double prime of x, equal to 0, and we're going to solve for x. If we do that, we get 0 equals 12x minus 6. 6 equals 12x, and then x equals 1/2. Now we know that we are going to have an inflection point at x equals 1/2. Now let's find where we're going to have our maximum and minimum points. So now for this one we're going to set f prime of x, or the first derivative, equal to 0. And once we do that, we are going to get 0 equals 6x squared minus 6x minus 12. If we go ahead and divide by 6 here, we get that 0 equals x squared minus x minus 2. And we can factor this to be 0 equals x minus 2 times x plus 1. Now from that we know that x can equal 2 or x can equal a negative 1. So those numbers are going to be our min or max points. And in the next step we'll determine which is which, if one's a minimum, one's a maximum, etc. So now in this step we're going to create a table. And this is the table that will kind of characterize our curve for us. So the first thing we have is the interval. And in there we're going to go from negative infinity all the way up to our first point. And our first point we see, or our lowest point, is going to be at negative 1. And that is one of our minimum or maximum points. Now we're going to do the next interval as being negative 1, because we want to figure out what type of point that is. Next we'll go from negative 1 to our next point. And our next point, if we look, is going to be the x equal to 1/2. Then our point will just be 1/2. We'll just say x equals to make that a little clearer when it's just a point. Then we'll go from 1/2 to our next point, which is 2. Then we'll have x equal to 2. And then we will have things greater than 2. Alright, so now let's look at our test values. So we want to pick out a value from each of these categories so that we can test it in our following steps. So if we're looking between negative infinity and negative 1, let's just go ahead and say negative 2. If we look between, or at x equals negative 1, we simply just do the point itself. Between negative 1 and 1/2, we'll just say 0 to make it easy. We have equal to 1/2 here. We'll just make this 1 to make it easy. You want to make easy numbers generally, if you can. Now in the next step, we are going to find the sign of the second derivative once we substitute in that test value. So the sign of f double prime of x when we put in -2, well, if we look at it, f double prime of x is equal to 12x minus 6. So if we put in -2, we're going to get it to be a negative result. If we put in -1, it will also be negative because we have -12 minus 6. If we put in 0, we're going to just have 0 minus 6, so that's negative. If we put in 1/2, it's going to equal 0. So it's kind of neither positive nor negative. And if we put in our 1, we get it to be positive. And if we put in 2, we get that to be positive as well. And if we put in 3, we get that to be positive. So now let's talk about our conclusion. What do these positives and negatives mean? Well, if you remember from some of our other videos, when you have a negative sign, that means that you are in a region that is concave down. So when we're at x equals -1, we're saying that's either a max or a minimum. And since the sign is negative, if we think of a concave down section of the graph, that means it's kind of like an upside down cup. So the point there is going to be at the top, so it's a max point. We're also looking at concave down section here. And since the f double prime of x is 0, we know that's our inflection point, if we didn't know that previously. Now we have a positive interval, so that's going to be concave up. We have a positive second derivative of a minimum or maximum, so that's like a cup facing upwards, so the point's at the bottom. So that's going to be our minimum point. And for our last interval, we have a positive sign of the second derivative, so that's going to be concave up as well. And now, from all this information, we can make a kind of sketch of what we think this actual curve looks like. So let's go ahead and make a graph here. Make our axes. Let's see. And when we do that, we know that we're going to have a max point here. We're going to have a minimum point here. Now we don't necessarily know how big of a max or min these are, but we're just going to kind of guesstimate. And we're going to have an inflection point at 1/2, so here. So that looks like a straight line. However, if we look at the concave up and down sections, we know that from -infinity to -1, we're going to have it be concave down. So that we can kind of draw like that. From -1 to 1/2, we also have it being concave down. Then from 1/2 to 2, we have it being concave up. And then from 2 to positive infinity, we also have it being concave up. So we've kind of just drawn a sketch of what we think our graph might look like based on the data from finding our minimums and maximums in our inflection point and finding out where we are concave up and down. So that is how you can characterize a curve.